Hello everyone. In this lecture we are going to see introduction of IC engine, and in that we are going to cover certain topics which are classification of an automobile IC engine, major engine components, and operation of four-stroke and two-stroke engine and some differences between the two. Okay, so let us go. Classification of IC engines. The very first and the basic classification that we have is depending upon the basic engine design. In that we have a reciprocating engine which are conventionally used. In reciprocating engine we have inline engine, we have V engine, and we have opposite piston engine, we have a radial engine. These are the examples of inline. As you can see over here, all the combustion chambers, that is the piston and cylinder arrangements, they are connected to a common crankshaft, and all these cylinders they are in a single line, hence this is called as an inline engine. Okay, then we have V engine. As we can very well see over here, this is the common crankshaft to which these two piston cylinder arrangements are connected through the connecting rod, and these two connecting rods in between themselves they make a certain angle, thereby forming the shape of a letter of V, hence the name. Then, as the name itself indicates, opposite piston or opposed piston engine, wherein the two combustion chambers of the piston cylinder arrangement are in a radially opposite direction with each other, that is, they are 180 degrees apart. The next is the radial engine. You can see over here that the combustion chambers they are connected along the they are present along the circumference of the circle, and a common crankshaft is present at the center of the circle to which connecting rod of each piston is attached. Okay. The next is the rotary engine, and the very best example for a rotary engine is a Wankel engine over here. We can see that these spaces which are enclosed between the chamber and the lobe they form as the combustion chamber and the compression space. Then another method of classifying the engine is depending upon the working cycle, which working cycle is present in the engine, or which working cycle the engine is running on. Depending on that, we have a two-stroke engine cycle wherein the strokes of the engine, that is suction, compression, expansion, and exhaust, they are completed within a single revolution of the crankshaft. Such an engine will be called as a two-stroke engine. And then we have a four-stroke engine wherein the four strokes, that is the suction, compression, expansion, and exhaust stroke, will be completed within two revolutions of the crankshaft. Another mode of classification is the method of ignition. By the word ignition, we mean start of combustion. There are different methods by which combustion of the fuel may start, and depending on that, the engines are classified. They may be spark ignition or SI engine, as we commonly call them, wherein a spark plug is used. In these engines, the ignition of the fuel it takes place by the means of a spark plug, and in these engines air and fuel mixture it is prepared outside the combustion chamber, which is called as charge, and this charge is drawn inside the combustion chamber, which is then further ignited by the passage of spark, hence the name spark ignition. Then another method of ignition is the compression ignition engine, wherein there is no need of a spark plug, because as the name itself indicates, the ignition of the fuel or the starting of combustion of the fuel is going to take place because of compression. Now it is important to understand over here that the fuel itself it is not compressed directly over here. Air is drawn inside the combustion chamber, it is compressed so much so that the pressure increases, along with it the temperature of the air increases, which goes beyond the self ignition temperature of the fuel. In this highly pressurized and compressed air having a very high temperature, fuel is injected in the form of spray, in the form of mist, and this fuel it ignites because of the rise in temperature of air, which is a result of its compression, hence the name compression ignition engine. Next mode of classification is method of cooling. We all know that heat is generated inside the combustion chamber. Some amount of this heat is converted into useful work which is available at the crankshaft. But there is a certain amount of heat which goes into the walls of the combustion chamber. It is extremely important that this heat is removed from the combustion chamber walls, and for this cooling methods are applied. The very basic method of cooling is air cooled engine, which we can commonly see in our bikes and scooters. Fins are present on the combustion chamber walls and also on the cylinder head. These fins they carry away heat from the combustion chamber, and in turn the draught of air which is passing over these fins as the vehicle moves, this draught of air it carries away the heat from the fin, and hence the method is called as air cooled engine. But in certain cases, when the capacity of the engine is very high, excessive amount of heat is generated, and air cooling by itself is certainly not sufficient to carry away the excessive amount of heat. If this heat is left over in the combustion chamber, it might very well lead to overheating of the combustion chamber, further leading to detonation and knocking and pre-ignition and the allied problems that come with it of the fuel. So also, excessive heating of the combustion chamber walls may lead to seizure of piston when it reciprocates. So, in order to avoid this, along with air cooling, water cooling and oil cooling may also be used, wherein a water jacket or an oil jacket is provided around the combustion chamber, where the heat carried away in the fins is taken up by the oil or water, and this oil and water is cooled by the draught of air. So this is a secondary type of a cooling system. Then again, we have classification of engine depending upon the fuel or the type of fuel it is used. We have a gasoline or a petrol engine. This is quite easy to understand. We have diesel engine. We have gas engine where we use CNG, LPG. Then we have dual fuel engine where we can see that many people they retrofit a gasket to their SI engine. Okay. Then we have a hydrogen engine wherein hydrogen is used as a fuel. We have hybrid engine wherein the mode of power supply is more than one. That is, you will have an internal combustion engine as well as you will have an electric drive to move to generate the required work. And then you have the fuel cell. Then other mode of classification is the application. Motorcycles, the amount of power used. SI engines are generally used, which may be two stroke and four stroke, and they are more often than not air cooled. Then you have outboard motor. Again, the power requirement is shown. The engine is a SI engine. It might be a two stroke engine, which is water cooled. Then you have passenger cars. Power requirement is 15 to 200 kilowatt. The engine type of engine used is generally a SI or a CI engine. It is a four-stroke engine which is water cooled. Then you have light commercial vehicles. Again, the power requirement is 35 to 150 kilowatt. SI or a CI engine might be used, which will be a four-stroke water cooled engine. Then again, you have heavy commercial vehicles wherein the power requirement has gone up. We can see it is 120 to 400 kilowatt. In such a case, SI engine does not is not compatible to generate such high amount of power. Hence, a CI engine is used, which is a four-stroke water-cooled engine. Then you have locomotives. Further, the power has increased. It has gone from 400 to 3000 kilowatt. Again, you need a CI engine over here, which is four-stroke and water-cooled. Then you have ships. Further increase in power requirement, 3500 to 22,000 kilowatt. CI engine, it might be a two-stroke or four-stroke, and it has to be water-cooled. Then you have airplanes, 45 to 3000 kilowatt. A four-stroke SI air-cooled engine is there. And stationary engines, you have 10 to 20,000 kilowatt of power requirement from them. A CI engine is generally used, which might be a two-stroke or a four-stroke engine, and the method of cooling applied over here is going to be water-cooled. Let us see what are the major engine components. This is a basic exploded view of an engine. showing different parts. The very first part that is the crankcase. Now in this crankcase, it serves as a vessel to contain the lubricating or the cooling oil. Also, it provides the surfaces to mount the bearings of the crankshaft, and it houses the crankshaft assembly. Coming to the crankshaft, this is the crankshaft. You can see this is an example of an inline engine. This over here is an example of an inline engine. Okay, so piston cylinder arrangements, they are connected to the single connecting rod. They are connected through connecting rod through a they are connected through connecting rod to a single crankshaft over here. Okay, and then after that you have connecting rods. Individual pistons are connected through individual connecting rods to the crankshaft. Whatever power is generated, whatever energy is generated through the rotary motion of the crankshaft, it is stored in the flywheel. This flywheel, it provides a surface for the attachment of clutch. Then you have the piston, which is the basic reciprocatory element of an engine, which transfers the work, which transfers the energy, which transfers the work, which is generated because of the combustion of the fuel in the method of reciprocatory motion, which is further converted into rotary motion on the crankshaft. Okay, then the next element is the camshaft. The use of this camshaft is to open and close the inlet and exhaust valves. This camshaft is driven by crankshaft itself through this timing chain or timing belt arrangement. Okay, depending upon the rotation of the crankshaft, the camshaft will rotate, and subsequently, as and when required, it will open and close the inlet and exhaust valve respectively. Then this whole thing, it is enclosed in the cylinder block, which is shown. This whole assembly, it is enclosed, the piston cylinder arrangement, it is enclosed in this cylinder block, which serves as the combustion chamber. Then you have the intake manifold. The function of this intake manifold is to ensure that the air is supplied in through proper channels to the cylinders. Okay, then after that you have the cylinder head. The combustion chamber or the cylinder block, it is covered by the cylinder head, which encloses the arrangement of valves and the arrangement of camshaft, and also it encloses the arrangement of fuel injector, which is our next component. So these are the fuel injector. Each individual fuel injector is present for each individual combustion chamber. Similarly, as individual fuel injectors are present, an individual ignition coil and spark plug is also present to ignite the fuel as and when required, depending upon the stroke which is taking place inside the combustion chamber. Then you have three-way catalyst. It is mounted in the way of the exhaust gases in order that harmful elements are taken out of it before releasing them into the atmosphere. Then you have the alternator, which serves as a power source. Then individually we'll see the major engine components. Cylinder head. This is an example of a cylinder head, and as we had already seen in the previous slide, these are the camshafts which are housed inside the cylinder head. They are mounted through bearings, and these are the passages which you see. They provide surfaces for attachment of the intake or the exhaust manifold. This highly machined surface that we can see over here around this passage, over here a gasket is fitted in order to avoid the loss of pressure and leakages. Okay, this is an example. This is a diagram of the cylinder head. What does it contain? It contains the valve driving mechanism, that is the camshaft and the valve train. OHC, it means overhead camshaft. It also houses the intake and exhaust manifold. It consists of upper part of the combustion chamber. The material is cast iron, steel or aluminium alloy. As you can see, it is a very big component, hence it is to be manufactured by casting, and further super finishing machining operations are to be carried out over here. Then we have the cylinder block. This is an example of a cylinder block which is attached to the cylinder head through dowel pins, and we can see over here that these are four cylinder engine which are arranged in line. These are the combustion chambers. Okay, again, this is a very big component. It is manufactured by casting and then further it is subjected to super finishing machining operation. This is an example. This is a diagrammatic representation of the cylinder block. Okay, look here, over here, gasket is timing cover gasket. This gasket, it means this oil pan gasket. Okay, this means that a surface is provided, a gasket is provided, an oil seal is provided in order to avoid the loss of pressure and leakages of the fluid. Then what does it contain? It contains the piston assembly, embedded water jacket for cooling system, and oil gallery for lubricating system. It has an installed water pump, alternator, starting motor, compressor, and the other allied components. It consists of upper part of the crankcase. It is made up of cast iron, steel or aluminium alloy. Okay. Cylinder head and cylinder block are fabricated by cylinder head bolts, that is, they are joined by cylinder head bolts, and they are sealed together by head gasket between cylinder head and the block. This is an example of a head gasket. Okay, and these are the bolts which serve as the joining points between the cylinder head and the cylinder block, and in between over here we can see the gasket. Fine. Then we have crankcase. This is an example of a crankcase. As you can see, it is nothing but in the sort of a pan. It houses the crankshaft assembly. Also, it serves as a container to contain the lubricant or the cooling oil. This is an example of a crankcase. As you can see over here, these surfaces are provided in order to mount the crankshaft assembly. Journals are provided in order to mount the bearings over here. It contains oil pump and strainer, engine oil, lower part of main journal bearing, consists of lower part of crankcase. Its materials cast iron, steel alloy or aluminium alloy. Then you have the piston head. This is an example, a diagrammatic presentation or representation of the piston. Piston is basically divided into two parts, the piston head and the piston skirt. Head is alternatingly also called as the piston crown. So this is the head of the piston. Here certain recesses are provided, that is depression in the head of the piston, which accommodate for the valves. When the piston reciprocates, it might go and clash with the valves, hence recesses are provided. And this is the piston skirt. Again, a hole is provided over here for mounting the gudgeon pin or the piston pin, which serves the function of connecting the piston with the connecting rod. Changes thermal energy to mechanical energy through connecting rod to the crankshaft. It provides surface for mounting the piston rings. It consists of the lower part of the combustion chamber. Its material is cast iron and aluminium alloy. These are the examples of different types of piston top. Here you can see that this is the flat piston top. Here it seems to be a dome shaped of a piston top. Here you can see that recesses are present on the piston head or the piston top. Then piston rings. We have three piston rings. The two piston rings, they serve to suppress the loss of pressure that might take place over here. As you can see over here, this is the combustion chamber wall. This is the surface of the piston. Now the important thing to observe over here is the piston is not in direct contact with the combustion chamber walls. Okay, instead of that, the piston rings are in contact with the combustion chamber walls over here. The third ring is an oil ring, which provides channels for the passage of lubricating oil in order to provide the necessary lubrication and cooling. Then we have combustion chamber. Combustion chamber is basically the area above the piston head or the piston top and between the cylinder head at the time when the piston is present at the top dead center. So when the piston is at top dead center, the area which is enclosed between the piston top and the cylinder head, it is called as the Combustion chamber. You can see over here different types of combustion chambers are shown over here depending upon their shape. The first one is a wedge shape. This over here is the combustion chamber. You can very well see that the shape of it is in the form of a wedge, hence the name. Then next is the bathtub. You can see the shape is like in the form of a tub, hence the name bathtub type of a combustion chamber. And then you have a hemispherical. You can see over here this shape, it approximates a hemisphere, hence the name as hemispherical combustion chamber. These are some images to support this argument. Let us go further. Connecting rod. This is a diagrammatic representation of the connecting rod. It basically has two ends. One is the small end, which through the piston pin or the gudgeon pin and the means of a small end needle roller bearings is connected with the piston. Then next is the big end of the connecting rod, which is connected with the crankshaft, again with big end bearing and the crank pin. This is an example of a split type of a connecting rod. Connecting rod may also be in the form of a single one piece component. These are the different examples of a connecting rod. It transmits force from piston to the crankshaft. It is connected with the piston and the crankshaft by means of piston pin or gudgeon pin and crank pin respectively, and of course by the means of needle roller bearings. The material used is nickel, chrome, vanadium, steel, aluminium. Okay, and the method of manufacturing is forging over here. Then you have the crankshaft. Again, we can see a diagrammatic representation of the crankshaft over here, and along with the connecting rod as well. So this is a crankshaft over here. Okay, different components that you can see over here is this is the journal. This is the weight balance, or weight balancer or balance weight you can say. These are the four crank pins you can see why this is a four-cylinder engine. So one, two, three, and four. These are the four crank pins over here. This is one, two, three, four. Okay, these are the four crank pins. This is the journal in between. Also, there are certain very small holes present over here. Okay, on this journal and the crank pins, so that passage for lubricating oil is provided. Again, this is an example of a it changes the reciprocatory motion of the piston into rotary movement. Different configuration depend upon the number of cylinder. It mounts the crankshaft sprocket and the flywheel. The material used over here is cast iron and nickel alloy. These are the different arrangements of the crankshaft. You can see over here this is the four-cylinder arrangement wherein the two consecutive crankshafts are separated by 180 degrees. This okay, this is 180 degrees between 1 and 2 and 180 degrees between 3 and 4. Then again a V8 arrangement wherein the consecutive crankshafts are separated by 90 degrees. This explains. Then V6 wherein consecutive crankshafts are separated by 120 degrees, and V6 splayed crankshaft. Again you can see over here with the diagrammatic representation. Then you have the flywheel. This is an example of a flywheel. It is nothing but an energy damper, or it stores the rotational inertia. It provides balance for the crankshaft, and it provides surface for mounting of the clutch and the transmission system in an automobile. It is meshed with starter motor's pinion gear on the outer gear. Its material is cast iron. Now let us see what happens in all these arrangements. They are assembled together. Which arrangements, which components? Piston, connecting rod, crankshaft, and the flywheel. So this is the piston. It is connected to the connecting rod by the means of a piston pin or a gudgeon pin. This is the connecting rod, and this connecting rod, it is connected to the crankshaft over here. This is a four-cylinder inline engine type of a crankshaft. Okay, and this crankshaft is further then connected to the flywheel. The next component is the camshaft. The very basic example, the very basic function of the camshaft is the opening and closing of the inlet and exhaust valve in order to provide the charge which is required during the suction stroke and in order to exhaust the combustion chamber, the combustion byproducts, that is the flue gases or the exhaust gases. This is an example of a camshaft. Lobes are present on it, and the valves, they open and close depending upon the motion transmission through these lobes. Okay, so here you can see that this is the crankshaft. The crankshaft rotates. It transmits its rotary motion through the timing mechanism to the camshaft. The camshaft rotates and it transmits its rotary motion through the rocker arm assembly. This is the rocker arm assembly with the return spring to the valve over here. Now, as the rocker arm rocks, this valve will open and close depending upon the rotation of the camshaft, which in turn is depending upon the rotation of the crankshaft. Okay, it operates the valve mechanism: open and close intake and exhaust valves. It is mounted with the cam sprocket. It is connected to the crankshaft by timing chain or belt. It is made from chiseled cast iron. Now we have operation of four-stroke and two-stroke engine. This is an example of a simple four-stroke engine. The four strokes that take place are intake or suction, compression, power stroke. Alternatingly, it is also called as an expansion stroke, and finally we have an exhaust stroke. All these four strokes, they are completed within 2 revolutions of the crankshaft, that is 360 and 360. So in a four-stroke engine, in 2 revolutions of the crankshaft, you will have one power stroke or one expansion stroke. This is an example of, okay, so this is an example of a two-stroke engine. In two-stroke engine, within a single revolution of the crankshaft, all the four strokes, they are going to take place. The intake and compression, they will take place simultaneously, whereas the power stroke and the exhaust stroke, they are going to take place simultaneously. Okay, this is an example of a two-stroke engine. You can see over here, when the piston is going in a downward, we'll start from this and then we'll come to this. Okay, when the piston is going in an upward direction, suction is created in this crankcase, and when the inlet port, this is the inlet port, when it is uncovered due to the suction created over here, fuel air mixture is drawn inside the combustion chamber, inside the crankcase. When this piston, it starts to move in a downward direction, this inlet port gets covered and the pressure on this charge, it increases. When the pressure on this charge increases, it goes through this transfer port. This is the transfer port, and it comes up into the combustion chamber. Now what happens is, when this charge will come up under pressure inside the combustion chamber, it will tend to go out through this exhaust port without being burnt. For this to not happen, the piston has a peculiar shape over here, and this is called as the deflector. This deflector, it prevents the charge to go out through the exhaust port without being burnt. So now when the piston has come in down, the charge, it has gone up, and now when the piston moves in an upward direction, this charge will be compressed over here, and at the same time fresh charge will be drawn over here. So compression and intake, they take place simultaneously. Now when expansion takes place, when combustion of the fuel, when the ignition of the fuel, it starts and its subsequent combustion goes on, the piston will move in a downward direction in the power stroke, and in doing so, as soon as it uncovers the exhaust port, whatever exhaust gases they are formed, they will move out through this, which is shown over here. Okay, so power stroke and expansion exhaust stroke, they take place simultaneously over here: intake and compression, power and exhaust. Fine. Application of a two-stroke engine: a very basic two-wheeler, lawn mower, speedboat engine, and a chainsaw. These are the differences between a two-stroke and a four-stroke engine, as we have already stated. One power stroke for every 2 revolutions, one power stroke for each revolution in case of two-stroke. The flywheel is heavier since this engine is unbalanced, because 2 revolutions of the crankshafts are taking place. in order to generate a single power stroke. Hence, some unbalancing takes place over here, because of which a heavier flywheel is required. Whereas in the case of a two-stroke engine, a lighter flywheel will serve the purpose. Because of a heavier flywheel, the overall weight of the engine is heavy in this case, and the overall weight of the engine is lighter in this case. The design is very complicated over here, because you need to accommodate the valve opening and closing mechanism, the camshaft, the timing mechanism, and so on and so forth, the rocker arm, the tappet, the return spring, and everything. But over here, no such thing is required, because we have ports over here. As the flywheel is heavy, the overall engine is heavy, the design is complicated due to the valve mechanism. The four-stroke engines, they are a little bit on the costlier side, whereas in the case of a two-stroke engine, they are a little bit low on cost. However, in this case, as you can see, mechanical efficiency is less due to more number of mechanical elements present and a large amount of friction. In this case, mechanical efficiency is more because less number of parts are there, and hence less friction is there. More output due to the full fresh charge intake and full burned gas exhaust. Here, each stroke takes place individually. No two strokes are happening simultaneously. So, in such a case, in suction and in exhaust stroke, the total amount of charge will be drawn in and the total amount of exhaust gases will be thrown out respectively. However, in case of a two-stroke engine, we have already seen that suction and compression, they take place simultaneously, and power and exhaust, they take place simultaneously. Hence, because of this, less output due to the mixing of fresh charge with hot burnt gases takes place. Here in this case, since a single power stroke is generated in two revolutions, the engine is a little bit cooler, and since a single power stroke is generated in a single revolution, the engine runs hotter. Because less power is generated, less fuel consumption is required over here, and since extra power is generated, extra fuel is consumed over here. These engines, they require more space. These engines, they will require less space. As the construction is complicated, so will be the lubricating system, and as the construction is simple, so will be the lubricating system. These engines, they make less noise, because for every two revolutions, one power stroke, and these engines, they will make more noise because for every revolution, one power stroke takes place. Intake and exhaust valves are present, as we have already seen, and inlet and intake and exhaust ports are present in addition to the transfer port, which we have already seen. More thermal efficiency here, less thermal efficiency because more fuel will be consumed. Less engine oil consumption, and over here more engine oil consumption, because in case of a four-stroke engine, the crankcase will contain the engine oil, which will cause the lubrication and the cooling, which does not get burnt along with the fuel. However, in case of two-stroke engine, we have seen that compression of the charge, it takes place partially inside the crankcase, so you cannot fill the crankcase with the lubricating oil, you have to keep it empty. Hence, you need to add the lubricating oil in this case along with the fuel. Hence, over here, more amount of engine oil or the lubricating oil is consumed. Since engine oil is present over here continuously, less wear of moving parts, and since engine oil is not present in the crankcase, more wear of moving parts. The applications mainly used in cars, buses, and trucks. And here, applications used in mopeds, outboard motors, lawn mowers, gasoline and marine engine and diesel engine as well. Okay, so this was it. Thank you very much.